still in most of the parts of east coast of India, you can see this. Mostly this is a small scale trawler, that is a bottom trawler. They mainly use this sail for, and that too during this towing time. Towing time means after shooting the net, they will set the sail, this sail against the wind direction, and then this gear as well as this vessel will be towed in the direction of wind. So still this is being used, though this percentage or this contribution is very less by this wind energy, but still it's using. So this is also a form of energy that can be used in fishing. Then third one is the fossil fuel. Fossil fuel, it's a dominant form of energy, and in mass scale it's being used in a motorized or mechanized fishing vessel. So actually this in the point of environmental thing, this is one of the major problem in the sense greenhouse gas emission or carbon footprint, like that I'll come in details in further slides. So as you know, this energy requirement in fishing, it's a fisheries sector as a whole is a highly external energy dependent sector, because you need to put external fuel for fishing, and after fishing when you are processing it, that is harvest and post harvest in both sector, it's a highly external energy dependent sector, and that too mostly depends upon fossil fuel, either direct or indirect. Indirect in the form of either this electricity generation, or directly in the terms of burning in the engines, so the fishing vessel is being operated. So this requirement, energy requirement, is an important criteria to performance evaluation of the food production system in the terms of energy input and then carbon footprint, because once if you burn fossil fuel, definitely it will leave some carbon footprint to the system, and that will degrade the environment and other associated things. So if you'll see from the energy perspective, fishing is a set of different processes, right from fabrication of craft and gear. If you'll see this gear, right from this extraction of the natural or synthetic filament, right from the beginning up to the landing the catch. So this whole set of different process, and it's a combined, you can say it's a combined set of this all process, and in every step this energy is being required, and on that basis we can evaluate the different sets, different between these two sets. So most fisheries energy input are required by fossil fuel to propel fishing vessels. So the major chunk of this energy is being used for the reaching the ground, then of course fishing also, and then come back to the shore to land their catch. So if you'll see this pre-industrial method and industrial method, mostly this is derived by like pre-industrial, mainly with the human power or wind for propulsion, then for hauling also animate energy they are using, then for processing mostly for preservation, either sun drying, smoking or salting. This is with the help of solar energy, and also for after processing when it's going to for end user use, that is a human or animal power they are using for transportation. But the scenario is different for industrial method, where the engine power is used for maneuvering to board to fishing ground and then to fishing and then come back to shore. Then hauling also with the help of mechanical hauler. Then processing in form of big freezers or ice, even production of ice requires a lot of energy. Then transportation to consumer with the help of either insulated cargoes or refrigerated vans. So this all requires huge energy. So if you compare these two, one is highly energy dependent one, and another one is with the help of some renewable energy. So most modern fishing is as we know, that it's a highly intensive method. So you can see this agriculture and allied field other than this fishing. Then production of rice, the ratio of input and output. Input energy, how much you are expending this production of rice, right from sowing the seed up to the harvesting. So this ratio is about 0.1. If you'll see this milk production, this ratio is about 1. It's how much you are going to expend the same amount of output in terms of energy you are going to get. Similarly for artisanal coastal fishing, but in case of distance water fishing, it's a highly energy consuming process. So whatever you are getting output in the terms of energy, actually you are going to expend 15 to 20 times more than that. So that's why it's a highly energy dependent process, and definitely there is some measures need to be taken care to manage this, to optimize this. So according to a study by Parker et al, it was in 2020, I think it got published in Nature. So they have estimated, they have analyzed some 20 years of data, and they have estimated about 40 billion liters of fuel consumed globally. Out of that, some 179 million tons of carbon equivalent, that is the 4% of global food production, that comes only from this fishing. So average emission also they have calculated on the basis of last 25 years data. So it also in context with some 90s, it grown by some 21%. This is a remarkable enhancement. In case of Indian scenario, the large scale industrial fishing sector, it's consumed about 14 million tons, and you will see this a smaller scale fishing sector about 1 to 2.5 million tons of fuel. Now, if you'll see here in this picture, this inputs and outputs. Input means whatever in the whole system, whatever you're going to utilize to capture the fish. So maybe it's a boat and gear, maybe you're going to consume a time, or in terms of fuel, then labor, then for preservation you're using ice, and then catch share. So after this all input, once you're applying this, and then you need energy for operation, then you'll be getting several output in terms of processed seafood, or in terms of money, you'll be getting employment. Then definitely after employment and money, community well-being will be there. Then some of the negative outputs like marine impacts. Definitely this fossil fuel will deteriorate the marine environment, so impacts will be there. Then waste generation will be there, and definitely oil and gas discharge will be there. So this is one scenario. And then coming to this energy requirement. So energy requirement will be based upon different steps in a fishing process. So first, this resource, what resource you are going to target, and what resource you are going to capture. Accordingly, you have to spend fuel. Then what is your fishing method? Because different fishing methods requires different energy requirement. Then what is your fishing ground? How far it's from shore? How far you're going from shore? And after catching, you're coming. So definitely you're going to expend some fuel in that. So that also depends upon the fishing ground. Then the processing. Processing, of course, we are going to process it with some high value processing commodity or low value. So energy, accordingly, it will be required for that processing. And then, of course, after processing, once it's going to the end user, what will be the mode of transportation, and how far is transporting to processing plant to market. So this all includes the energy requirement, and then how it differs. Then coming to different fishing methods, I think yesterday Dr. Sally Madam has already described about different passive gears and how it operates. So I'm not going very detailed in that. But if you'll see the energy, in the part of energy requirement, if you'll see this long line and gillnet. So long line and gillnet, most of the chunk of this energy is going to expend in the going to fishing ground and then coming back. So actual searching the fishing ground will cause more fuel use, and then coming after catch, coming to this shore. Then remaining this setting of fishing gear, mostly setting of fishing gear will not be so energy intensive, because during that time a vessel will be moving with a very low speed, and after setting the net, normally fishermen used to switch off their engine, and they'll be waiting. After completion of this soaking time, they will harvest, they will haul, either mostly in the mechanical form. So waiting will actually it's very less energy intensive. So for this type of passive gears, gill nets and long lines, only this reaching to the fishing grounds and coming back is an energy intensive. Then coming to this 2-3 other things like purse seine, trawl, and trawling and trawl. That two different methods. So in trawling, definitely where you are having a back shaft net and you are towing behind the vessel. So in that, towing itself is a highly energy intensive, because you are dragging a net behind the vessel, so there will be so much water drag will be there. Then this because of this resistance, fuel use will be more. So this reaching the ground and coming back to the ground, it will be not that much energy intensive as compared to main towing. It's not moving. It's moving. Moving? No. Okay. One second, please. Now it's moving, but here it's not moving. But I cannot move it now. Thank you. Sorry for inconvenience. So I was telling about this trawling. So in case of trawling, the major energy consumption will be for towing the gears, and the going to port fishing ground, and the coming after a catch coming to the port, it will be not that much energy in case of trawling. But it will see the another trawling. In that trawling, again this going to port and coming back from port after catch, that two process, this process and this process will be energy intensive, and this actual fishing will be not that much energy intensive. So this is the case of trawling and trawling. Now coming to this Percing means definitely where you're going and you're surrounding the catch, but surrounding the shoal of fish, surrounding the catch, first you have to scout, you have to search the fish. So this process, going to fishing ground, then after catch coming to the ground, and then searching the fish. These three part of the fishing is energy intensive, remaining either hauling or loading, because it's a very fast. After getting the shoal, you are just encircling the shoal and you are catching the shoal. So this all will be less energy intensive. Now I think already yesterday one of the speaker have described about this different fishing method, and then how much kilogram of fish is landed per kilogram of fuel burn. So you can see this trawling, then percing and gill netting. And then if you take one part, like if you take trawl, then there are different parts in trawl. So out of every part, how much they are going to contribute towards fuel consumption, because every part is having different properties. Like netting, it's sieving more water, so drag will be more, so resistance will be more, so you are going to burn more fuel. So netting contributes most, and remaining other accessories like floats or water boats, foot rope, so this contributes less than the netting. The same pictorial representation in the form of other diagram, like net, trawl net itself. Now this is a estimation of fuel consumption by Global Fishing Fleet. Already I told in earlier that Parker et al. Has conducted a survey, a study, and he analyzed the data of 20 to 25 years. He found that total fuel consumption of 40 billion liters produces some emission of 179 tons of carbon equivalent. And he has categorized, he has specified so many things, and under so many different categories, like whether vessel type is motorized or non-motorized, or it's a wild product type, or type of species group, like it's a pelagic or demersal or region wide. He has nicely analyzed and he has presented so this. And if you'll see this different landing of different group, like whether it's a pelagic or whether it's a demersal, and related to their global house gas emission. So you can see this demersal and reef fishes, this contributes more, and its landing also contributes more towards this, and remaining like cephalopod or mollusk, for that this emission is comparatively less than this. Of course crustacean, because mostly they are using this bottom trawl for this shrimp and all harvesting shrimp resource. So here also some large amount of energy is required. Now coming to this estimates of production and global house gas emission by fishes of different countries. So here you can see this landing a different part of world, and accordingly their landings and their global house gas emissions. So here if you see the landing wise, of course this China, then some of the parts in North America, then of course this Peru coast and all, this also contributes more towards landing. But if you see this global house gas emission, of course this China is on top, and this is out of this 40 billion liters of fuel consumption. So accordingly this global house intensity will be more. Here you can see this Australia, because intensity is more because they are using they are burning more fuel to catch a particular amount of fish. So that's why you can see this it's under only 500 to 1000 tons of 1000 tons of landing, but for that they are they are burning more fuel. That's why this intensity is more. And if you see this global fleet operation cost by factor, then fuel is this is 93 one study. According to that, it's 15%. But now, if you see the most major fishing, if you take this total operation cost, maybe it's going like 50 to 60%, or even 55 to 60% of total consumption. So fuel is one of the major operational factor in terms of cost. And in terms of percentage of labor cost also, it reaches like some 50 to 70% in that sense. Now if you take this total world's fishing fleet and total fuel consumption, so it's a total consumption, some 1.2% is consumed by fishing fleets only, and which represents, it's out of total, irrespective of this fishing methods or fishing gear, this 0.67 liters of fuel they are burning to get 1 kilogram of live fish. So this is one thing. And then if you see this percentage of revenue by country, then India's share towards fuel cost is about 28 to 30%. Now I already told it's already gone beyond this 30%. Maybe this is now it's a 55 to 60% in terms of operation cost. And now you see this Indian context. Here this different fishing methods like mid-water trawling or bottom trawling, or it's a deep water long line. Everywhere this energy they have quantified. So for how much fuel consumption is there in liter to get 1 kilogram of fish landed. So if you see this coastal fishing, it's very less, because mostly they are utilizing this animate energy for this in most of the case. And this near water because motorized, because of this small motors they are using, maybe this is having less value. But in case of deep water long line as such, after shooting they have to wait for that up to soaking time. So that part engine is getting completely stopped. So that could be the probable reason for that less consumption. And of course trawling is one of the highly intensive energy operation. So in case of trawling, you'll get you have to burn more fuel to get a unit mass of the catch. And if you take the types of vessel, different types of vessel, whether it's a large mechanized or a small motorized, or some gill netters or bag netters, so these all are definitely having less energy intensive process compared to this large mechanized boats. And of course trawler is as I told, trawler is one of the high intensive fishing methods. This is studied by Vivekanandan et al. And if you see this total annual consumption of petroleum products in India, then the fishing fuel consumption is about 1.26% of the total consumption. Where this you can see this large scale fishing sector and the smaller scale fishing sector contributes like 15 to 1 to 2.5 million tons of fuel. So what could be the cause for that? This much huge intensive fishing requirement, fuel requirement. So one could be this whole process is highly energy dependent, and then it requires energy at every step, right from the construction of fishing vessel or gear up to the landing of the catch. And then this availability of fossil fuel. This is one of the, if you are having money, if you'll have money, then you'll spend for a lot many things. If you'll not have money, then you'll not spend. So similarly, we are having the humankind, so having this fossil energy resource. So we are spending towards everything, and since so fisheries also. And then this dominance inside of Indian. Now, recent past, it has been noticed that step by step over the year. Now, before it was a less HP engine, less power engine. Now, they're using more and more and more. So, continuous increasing and this dominance of the size of engine. This resulted this enhanced fossil fuel. So, there are so many out of competition also. Then reaching the fishing ground faster, then catch more fish. This all intention is increasing this fuel consumption. This more and more. Then is enhancing fishing effort also. Actually, for catching a particular resource, actually we want some only 5 fishing boats, but instead of 5 fishing boats, actually we are operating with some 25 fishing boats. So this enhanced fishing effort also plays a major role in more and more fuel burning. Then of course this, if you leave this animate type of animate energy system like artisanal system, then motorized mechanized fishing is totally based upon fossil fuel. So this all could be the reason for that. Then what actually happened after this burning of the fuel? So definitely the greenhouse effect and this toxic pollutants are getting emitted to the environment, and actually it's a irreversible climatic and oceanographic changes. So it create many problems, many damages to the environment, and actually this at some extent this is required because it acts as this all greenhouse gases acts as a blanket over the planet. So our planet is getting that much enough heat to sustain the life, but at a certain extent only. After beyond, if it's going, it's creating many problems. It's getting warmer every year. So these all are the consequences of fossil fuel. Now coming to this life cycle assessment. Life cycle assessment is a method to systematically assess potential environmental effects. Out of this, if you're taking this fuel as a criteria in fishing, then out of burning of the fuel, what all different environmental impacts you're going to create. So this all systematic assess that environmental point is one of the scope for life cycle assessment. Then compilation and evaluation of that inputs and outputs. Once you know the inputs and you don't know the outputs, then you can evaluate it. So it's also coming in the purview of life cycle assessment. Then this very purpose of this life cycle study is to assess the environmental impacts or potential product substitution. Whether if you are using, say for example, for construction, if you are using FRP, this much of emission or this much of greenhouse gas is going to emit in the environment. So whether any replacement can be made out of that. So this type of study also can be done with this life cycle assessment. Then identify opportunities to improve. Again, this if it's not possible to completely replace the particular step or particular input, then what could be the probable improvement in that? That also it's possible. And of course, if you know everything, then it's a very good tool for decision maker to understand the things or make the policy, make the guidelines, etc. So in fisheries and aquaculture, LCA was introduced in 2000s, and worldwide many authors have reported their work based on this life cycle assessment in fisheries. And in India also many authors have reported their findings, and mainly from ICAR-CIFT, this work they have contributed a lot towards this fisheries sector, and that too mainly confined with harvest sector only. So if you'll see different approaches in LCA, so just you take example of here I have taken example of a fishing boat construction. So first you can see this. There are 4 major approaches. One, cradle to gate, then gate to gate, then gate to gate, and then cradle to gate. So first you take the example of construction. So you can see this here raw material. This raw material is going to process. So this is a boat building material. This boat building material, it's after construction process, it's going to turn to fishing boat. Now in fishing boat, up to this level, it's like cradle itself is depicting that from initial, from starting to gate position. From here, it's actual enters in the fishing operation. So up to this, if you're analyzing this approach, is called cradle to gate. Now this system enters into the operation. So you put the operational inputs like fuel or ice or lubricant oil, whatever. Then it going to the fishing, actual fishing. After fishing, this catch is coming. So up to this point, it's a cradle to gate, because you can again assess. You can again assess this whole thing from after operation, one operation. Again, you turn to this point. You again give the input, operational input, like whatever fuel or ice or lube oil or labor, and again you continue this process. So this is again one process. So this is called gate to gate approach. Also it's called open loop approach. And if you are considering this disposable or waste, like in case of vessel it's a decommissioning, so if this thing also you are taking in account, then the whole thing will be like cradle to grave. So right from starting up to the end, it's a cradle to grave. If it's from operation part up to the waste disposable or recycling you're taking, then it's a gate to gate. If it's an open loop, only you're concentrating on the operation part, then it's gate to gate. And before coming to the operation part, if you're taking, this is cradle to gate. So these are different approaches in LCA. Then coming to this product page. So normally it's a complementary set of environmental rates, mainly helps in contributing this carbon footprint. And this what is a greenhouse gas emission? So some of emission from the value chain of the product or process. Either it's a product or process. So it can be, now what is the value chain? Value chain means right from beginning you take extraction of natural resources or raw material, then you give some different particular amount of energy, and then production will be there. Then after production you have to maintain our this particular product for operation. So this is called value chain. So during this value chain there are chances of lots of emission of greenhouse gases. So this, if you are analyzing a value chain, so this will come under the purview of GCH and carbon footprints. Now if you see this product page, so the same thing I have already explained, this from natural environment, then raw material extraction, and right from all the process you are coming, and finally this is the process of recycling, or whether it's if it's a recyclable, you will recycle, otherwise it will go as a waste for landfilling and all that. So these three things, like either it's the material recycling or component reuse or product reuse. Because material recycling after raw materials, again it will come and it will enter in this field. In component reuse, if there is some problem with this after processing, you will form the unit. That unit, building units. This building unit, again it will come to this loop. So like this. And then product reuse, after assembling and packaging, once the product is ready, or this is also applicable in the case of process. So instead of processing this ready, then again it will come to the loop. So this is called product phase. Then coming to the system boundary, this is one of the important aspect in life cycle assessment. In system boundary, nothing but what else things out of the whole set of different for a process or for a product, there are different sets of to complete that process. What all things you are taking in consideration, and those things will be only in system boundary. So apart from this, suppose I told you like cradle to gate. So cradle to gate means right from production of that particular product up to a particular point. So only you are taking that much up to before entering to the fishing operation. Just like in case of construction of fishing crafts. So fishing crafts means right from the construction up to just before launching to the fishing operation. So up to construction, if this is your study area, then your system boundary, all elements will be just before the construction. So what all things you are going to take on the basis according to your goal and scope. So this all will come under the system only. Like here, if you see this case, so this is the system only. So here for a product, you're thinking about raw material acquisition for manufacturing, reuse, maintenance, and then recycle. So in this, whatever come under the purview of this will be your system only. And in system only, your input will be like raw material. Definitely you are going to produce a product, and some raw material will be there. Then energy, you have to expend energy, and then out of that, so many outputs will be there in terms of waste, in terms of emission. So this is system only. This is one of the important thing in assessment to fix your goal, especially. Then importance of LCA in seafood. So now this when the concept of this eco-labeling, there are so many certified agencies are there. They are actually certifying the products. Okay, this product is produced sustainably or responsible in the responsible way. So now we are going to if you go to the market, you'll get a shirt or pant. That shirt claims that okay, for production of this shirt, only this much carbon footprint is being emitted. So the lesser the value of carbon footprint, that wearing that shirt will be more responsible towards environment. So the same concept in case of food production also. Now we are thinking about so many different eco levels. Like in case of fishes, MSC, this Marine Steward Council, they're certifying some catch, some particular fishery where they are telling that okay, this fish is being harvested in a responsible way. Similarly, LCA plays a major role there, because at every step you can know the energy expenditure in that, and if it's beyond the limit, definitely you'll be telling okay, this is not good, and if it's less than that, you'll be telling okay, this is good, we can have this. So this is one of the importance of LCA in fisheries, and of course in eco-labeling also. So this is some of the definitions. I'm not going through. This will be provided in your notes. So this all are self-explanatory. You can go through. Now there are different measures, the different measurements in LCA, where with these indicators we can know how much it's going to impact the environment. So there are different like abiotic depletion potential, then acidification potential, or eutrophication potential, or human toxicity potential, or marine ecotoxicity potential, or its ozone depletion potential. So these are some different standards. With that you can make out the okay, with this process or for this product, this indicators will have a value. With this value we can make out okay, this particular product is going to harm environment in this way. Then main application of LCA. So if by performing LCA, analyst can know environmental consequences of the product and process in terms of emission or in terms of environmental burdens. Then analyze the environmental traits associated with the specific products or processes. Then of course this environmental related to air, mainly in the terms of emission, we can make out either to air or water or to land. Then environmental shift also we can make out between this life cycle stages. So one life cycle stage, okay, in a particular process or particular product formation, particular set of stage is having this much, or another stage is having that much. So that we can make differences. We can shift that impacts. Then human and ecological effects of material consumption and environmental release. Of course, that is a basic thing for acquiring this unit input. And then of course compare the health of ecological impacts, how it's going to deteriorate, whether it's a less or whether it's a more, and then identify the impacts of one or more specific environmental areas of concern. That is depends upon your study area or your scope or your goal. Now coming to this framework, there are majorly there are four. Already it's a system only. I told you what is system only. So there are actually it's a 5 component, but out of this, if you exclude the system only, one is the goal and the scope, then inventory analysis, then impact assessment, and then interpretation. So in goal and scope, what we are doing, we are setting the goal, we are fixing the goal. Based upon that goal, your everything will get changed. Whether your input will be getting changed, your calculation will be getting changed. So it's for either product or process design or for its improvement. Then after commencing this, you can give this information to the product. Okay, this product is going to emit this much. Like this, it can be used. Then for granting a eco level, it's very much essential. Then whether after analyzing this, whether it's in case of product, if it's it should get admitted into the market, or already if it's existed, it should get removed from market. That also, this type of policy decision you can take. And then lots of policies regarding that, the purchasing or waste management, huge product range also you can decide after this setting this goal. So these all are the goal. Then this functional unit and reference flow is very important in life cycle assessment, because functional unit is the basis for selecting and a more alternative system. So this is basically will be your shortest or smallest unit. So on that basis, you can select, okay, if it's a fit in this system, whether it could be fit for another life cycle processes or not. So in case of like fishing, you're landing catch. So functional will be the unit mass of the catch. How much unit mass catch you're getting out of burning that much fuel. So this is functional. And this amount of functionalities is how much necessary to fulfill the function. If you're quantifying that, that will be reference flow. So some of the example I have given, like fishing, in fishing operation, it will be the kilogram of catch landed. In fishing vessel construction, the unit weight of input required, how much you're going to spend steel, or it's a nail, or it's electricity, in any terms. Then in case of electricity, either it's amount of energy, or amount of energy means either in terms of megajoule or how much kilowatt in hour, the same thing. Then like packaging, it's how particular size, how big it's in the pack of liter or kilogram, whatever. Then if some illuminating thing is there, then you have to mention the time, and then specify this luminous flux, whatever. Then if it's a discarded box, then it will be the amount of the cardboard or amount of this packaging things. Then if it's a paint, then what is the area and how much time it's going to be there. Like in there, we are spending this, we are mentioning this time also. Similarly for transportation, if it's people transportation, that means how many persons and how many kilometers. Then for good transportation, what is the weight and what is the distance. And coming to the second, this is inventory analysis. This is after selecting the goal and scope, you have selected the different inventories. Okay, this particular things, like 5 different things are required to produce the product. Then everything will be like inventory. Now you are analyzing this inventory. So one inventory will cause how much environmental burden, or how much it's going to deteriorate the environment, that you're analyzing. So either it's in form of material or it's form of energy, or output will be either waste or emission. So this is called inventory analysis. Then I'll tell 2 scenarios, where one, you take the construction of fishing boat. So in this construction, the first, like this is fishing boat made up with a wooden fishing boat. So first you take the tree, harvest it. So this will form a log. That log will go to wooden yard. It will be converted into wooden chips. Then with some pre-processing thing, here you are giving the chemical and resin, whatever. So this will be your input. Then it will go to the boat construction yard. In boat yard, again you are putting some other inputs other than wooden log. And that after that fishing boat will get ready. That will go to the fishing operation. And in fishing operation, here energy will be required. So after that, it will be decommissioned. So this all individual steps. In that all individual steps, what all inputs is required, that is comes under inventory analysis. You take a second example of fishing operation, where after construction the boat, this boat is going for a voyage. This voyage, before voyage, so many operational requirements, inputs will be required. That apart from this, once it will start, it will scout the shoal or scout the fishing ground. In that, fuel will be required. Then the actual fishing operation will take place. It will then fish catch. Again, here energy will be required. And then after processing, value addition, this will be after getting product, it will be waste generation or disposal. So here also, this phase also, it will require energy. So each and every step you are going to analyze. So this will be your inventory analysis. Now data collection is one of the important thing in LCA, because before fixing the your goal or your scope, you're going to set how you're going to collect the data. So sometimes initial decisions are not practical. So after setting the goal, you need to review it. So sometimes you feel that okay, this is my goal, but the data collection, the way there are different methods. So this method is not suitable. So review is required to change that. Again, some important choices initially maybe would have forgotten. So that also you can include. And sometimes your project is not too ambitious for time and budget. So this data collection and then review, it's very important. Then foreground data and background data, there are two types of data. So foreground is directly related to your production process, and those who are supporting this apart from this data like electricity or transport process or waste treatment, these all will be under background data. Then coming to the impact assessment, after this inventory analysis, you have to understanding and evaluating this assessment. So in terms of magnitude or in terms of significant potential environment. So this will be coming under impact assessment. This is the process. This is the step where you are actually going to know that because of this particular component, particular input, how much damage is going to cause. So like this, you see carbon dioxide, maybe it's responsible for climate change. If you take methane, it's maybe responsible for climate change. At the same time, this photochemical oxidation formation also, it's because of methane. If you take chlorofluorocarbon, maybe because of maybe it can cause this climate change, and at the same time this